Let's do an example here of solving a rational inequality. So here we have this inequality here. The first thing we want to do is bring everything over to the left, right? Over one side of the inequality. And so what that's going to do is give us what? That's going to give us 4x minus 5 over x minus 2 minus 3, because I'm going to subtract 3 from both sides, and I get this. So now what I want to do is I want to simplify this side here by getting a common denominator and simplifying. So I'm going to multiply the top and the bottom by x minus 2. So that's going to give me 4x minus 5 over x minus 2 minus 3 times x minus 2 over x minus 2. Okay? And so now I'm going to combine the terms, right? And so this gives me 4x minus 5 minus the whole quantity. So it's going to be minus 3 times the quantity x minus 2, because remember I'm subtracting this whole thing. And I'm going to write it all over x minus 2. Now I'm going to come up here and continue. So I'm going to simplify this. So I'm going to distribute the minus sign and just simplify this. So this is going to give me 4x minus 5 minus a 3x minus a minus, so this is going to give me negative 6, but the minus is going to give me a plus 6. So all I did was distribute the 3, right? That gives me 3x minus 6, and then when I distribute the negative sign, the minus sign, I get minus 3x and then plus 6, okay? And that's all going to be over x minus 2. And now, again, the inequality here, we want to set that equal to 0, because now we want to solve for all of the solutions, right? So I'm going to simplify this. So 4x minus 3x gives me x, right? So that's just going to give me x. And the net minus 5 and the plus 6 is going to give me 1. So this is just going to reduce to, or simplify to, what? X plus 1. So all I'm going to get is x plus 1 over x minus 2. So now I want to find all the real solutions. So all the real solutions are going to be what values of x give me 0 here. Okay? Which means I'm focusing on the numerator, right? So that means the only value of x that will make this whole function 0 is negative 1. So x equals negative 1 is a real solution. Now, because it's a rational expression, I also need to find what are the values of x that will make this undefined. And that's going to be when x is equal to 2, because when the denominator is 0, that's when the expression is undefined. So when x equals 2, that's going to be an important point. Okay? So again, why am I getting these points? Because these are going to be my boundary points of the intervals that I'm going to test. All right. Now that we've done that, let's see what's going on here. So we end up with, again, it simplifies to x plus 1 over x minus 2, and it was what? Less than or equal to. So less than or equal to 0. So that's what we're dealing with. We've got our boundary points here, so let's set this up. So we have our interval. One interval is going to be from negative infinity to negative 1. And then another interval is going to be from negative 1 to 2. And then another interval is going to be from 2 to positive infinity. So now let's test the signs, right? Okay, if we put in negative 2, we get negative divided by a negative, which is positive. So that's going to be positive. If we put in 0, because 0 is easy, if we put in 0, we get negative 1/2, right? So that's going to be negative. If we put in 3, we get a positive over a positive, which is positive. All right. So, our solution set. So we want everything that's less than or equal to 0. So the equal sign means we're going to include the endpoints. Okay? Except, well, 2. We're not going to include 2 because 2 is where it's undefined. So we cannot include 2. Okay? In fact, if you remember, there's a vertical asymptote at x equals 2. Okay? So we cannot include 2, but we can include negative 1. Now, we want everything that's negative or 0. So that means it's going to be this interval. So our solution set is going to be what? Negative 1 to 2, but does not include 2. So the solution set is going to be that. Or we can write in set builder notation the set of all x such that x is greater than or equal to negative 1 and less than 2. All right, not bad.